C++ compilers don't interpret the source code line by line, and they don't execute it on the fly. What a C++ compiler does, it makes a translation of the source code, which is a file of characters, into a binary file, which is the executable form for the CPU. So this has some implications on how to organize the source code, a source code file. What we shall see in the next example now is how to organize the proper order of the function definition and the invocation of the function. Let's start with a simple Hello World template again. If you don't have it, then create it. It's a simple C++ console application, non-Qt console application, and once you have it, go on with this lecture from this point. So in this exercise we shall create a little function adding two integer numbers, and then we shall invoke this function. Let's start with the definition first. Because we like to organize our programs in a well-readable way, and because the theory of abstraction says that we always start with the highest level of problem solving. In this case, the highest level of problem solving is the main function, and all the details would be very nice to be put underneath. So let's start here on the bottom with the little addition function. The return value will be an integer, so it's int int. The name is add, and the two parameters are also integers, int a and int b. And all it has to do is return with a plus b. If you build and run this program, it will run, because all it has to do in the main function to print the hello world message. Add is not invoked. What we do, the next, is to invoke the add function with just two random numbers. Let's say, just set an example, 3 and 5, and that's it. Run. But this time it will not run. We get an error message stating add was not declared in the scope. What's the problem? The problem is the C compilation happens in basically two phases. The first phase is the compilation of every one individual CPP or source code file. In the result of this compilation is it's actually the compiled, translated source code in the assembly form now, but the symbols of variables and functions are still there, because without all the other modules, the compiler doesn't know where the final place of this certain symbol will be in the memory. So before it can give it a memory address, it has to see where are the other modules in memory and how big they are. This is only known by the linker, which then will merge all these pre-compiled object files into one big executable. But in the first step, the compiler can only see this only cpp source code. So when it gets to this point where we invoke add, add will be without any previous information. The compiler, however, will require at least two types of very important information. The first type is what is the type of the return value, and the second information is what is the type of the argument list, the parameter list. It needs it because although it doesn't have to copy the real solution of how add works into this place, all it does, it will just represent it with the symbol, the name of add, but it has to organize how to get the parameters back, get the result back from this function, and how to pass the parameters to this function. So to do that, the compiler needs the types of the return values and the parameter list. So how we can fix this problem here? The simplest way to fix this issue is to cut it out and put the function at the very beginning of the program before add is actually invoked. Now, if we run it, it will work. So it is nice, but we have a problem. If functions refer to further functions, this structure of organizing the order of the function definitions will lead to a mess, because we try to keep everything in order by means of the order of the functions. These secondary and further references may cause endless cut and paste in the program editing. So C++ provides a better solution to go around this problem. Let's put this function back to the end of the file. Yes, and now what we do is we just inform the compiler by copying the first line of the function definition to the very beginning of the source file here. Because there is no definition, we have to close it with a semicolon, and this is it. This way, when the compiler gets here, it will get the information about the return value and the parameter list, and by the time the invocation happens, it will have all the necessary information. So if we run it, it will work.